So as I said, we add the noise, the gumball noise to that. And finally, here I can, it's here. It's hard to backpropagate because argmax and all of these things are discontinued things. So in order to smooth it, we use softmax, but the way we represent it is adding noise to it. So if you add noise to that and use softmax, then we can backpropagate. And these papers, you can see the gumball trick in all of these things. It has a profound theoretical background. And we are here. So I said that we quantize that, and this is just the quantization model. And here you will see that you can backpropagate safely because it's smoothing. And then we use masking as usual, as we do masking in any transformer or anything. But here we use CNN, convolutional neural networks, and then CNN, and then transformer. So we mask a proportion of the feature encoder outputs, but we randomly sample without replacement a certain proportion of all time steps. And the total loss, it has two losses. First of all, it has a contrast. This is the contrastive loss, which is, as you have seen the paper, contrastive. I forgot the title of the paper, but you see all of these things are very similar. You have this different similarity measure, and when your context and output is very similar to a specific quantized representation, then our loss is small. But you do it to create a contrastive loss. But diversity loss is just the entropy of softmax, because we want to reduce this entropy, this diversity loss. And you will see that if you run that algorithm, it can provide a better word error rate. And here you can see that for example, for this work, if you use clean data, it is 1.6, which is much lower than your, for example, let's compare it with ContextNet, which is 1.9. Or we can compare it with CTC and sequence to sequence, for example, this article. So it is better than all of them. But it is almost the same for noisy student. And also you can use phoneme recognition accuracy in terms of phoneme error rate. For this work is 7.4. PER stands for phoneme error rate. If you compare it to a previous version of Wave 2 WEG, which is this one, it is much better. If you compare it with PASE article, if you can compare it to Filter Bank's article, it has much lower error rate. And I love David Hilbert. Mathematical science is, in my opinion, an indivisible whole. An organism whose vitality is conditioned upon the connection of its parts. Maybe it means that you should know discrete mathematics, continuous mathematics, and the relation between them. Maybe you should know topology, geometry, analysis, probability, and to see the connection between them. Maybe you should know harmonic analysis, functional analysis, and the relationship between them, and signal processing, the relationship between them. So you should have a holistic view of mathematics if you want to be productive in computer science and machine learning.